In this video, I'll share with you 7 CAD tips that experts do that you might not. And applying these 7 tips will allow you to create more robust models, speeding up your workflow, and allowing you to create more complex geometry with ease. When I first started doing CAD, I didn't know all of these tips, but I've learned them over the years by watching experts and by analyzing the models they create. Let's jump right in with the first tip. Number 1, do math within the dimension entry box. A beginner thinks it's smarter to do the math in their head. An expert leaves a documented trail of decisions. I'll show you what I mean with this design. This is a water bottle cup holder that you may have seen in a previous video. I designed this cup holder to perfectly fit my Yeti water bottle and to slide perfectly into the cup holder in my Toyota Corolla. And if I open up the sketch here and I open one of these dimensions, you'll see the equation that I typed in here. And what this tells me is that the measurement I took when I measured my water bottle was 3.765 inches, and I added 0.010 of an inch as clearance so that the water bottle would slide in and out freely. And if I look at any of the other critical dimensions in this design, such as the top diameter of the cup holder or the depth of the cup holder, you'll notice that I've done the same thing. And so it's easy for me to remember what measurements I took when I created this design. So doing math within the dimension entry box will not only prevent arithmetic errors, but it will also help you remember why you chose your critical dimensions. Number 2, use variables. A beginner may get good at hunting down the dimension they're looking for. An expert will have already named it and stored it as a variable. So which dimensions should you store as variables? There'll be dimensions that are likely to change and that drive a large part of your design. A good example is this cylindrical snap bracket that I designed in a previous video. And you'll notice that if I go to where the variables are stored, there's a variable called diameter, and this is for the diameter of the handle that this snap bracket is designed to hold. So if I change this from 2 inches to 1 inch, you'll see that the entire design will scale with it to accommodate that new 1 inch handle. And if I go into my sketch, you'll notice that some of the dimensions have this little function symbol next to it. And what that means is if I open it up, I'm calling a variable that I've created, in this case, the diameter variable. And that's what allows this design to scale by changing that variable. Another time when you'll benefit from using variables is when there's a dimension that you're going to call repeatedly throughout a complicated design. Here I have a little Plinko game that I'm halfway through designing, and before I even started this design, I created a few variables. You can see them here. I have coin diameter, which is the diameter of the little token coin that I'm going to drop into the game, the peg diameter, and spacing, which is a function of the coin diameter and the peg diameter, plus a little bit of clearance. And you'll notice that as I go through these sketches, almost every single dimension has that function symbol. That's because almost everything in this design depends on the diameter of the coin and the diameter of the pegs. And you'll even notice that within my features, I'm calling these variables. And so if I ever decide that I want to change the size of the pegs, for example, maybe from 0.125 to 0.1, you'll notice that the whole design scales with it. And if I wanted to use a larger coin, let's say, instead of 1/2 inch, 1 inch, then the whole design would scale so that that coin will be able to fit between each of the pegs. So if you use variables, you'll be able to find and update the critical and dynamic dimensions within your designs weeks or even months later. Number 3, build geometry you don't need. This one seems counterintuitive, but a beginner thinks they should only model geometry that will become a part of the final design. An expert will build geometry that they don't need in order to use it to build something they do need. There's a great example in this pair of bevel gears that I created. If I roll this design back, when I created the first tooth, I actually used a bit of a shortcut. I used a plugin that's available in Fusion that generates a spur gear. So if I activate this plugin, I'm able to input parameters such as the pressure angle, the diametral pitch, the number of teeth, and by selecting the parameters that I wanted, and just do some example parameters here, I was able to generate a spur gear that had the tooth profile that was going to be a good approximation for the bevel gear tooth profile. And then I went through and projected it into a sketch, deleted the features that I didn't want within the spur gear, And as we move through the timeline, you'll notice that at one point I actually remove that tooth altogether. So here is where I have the tooth that I grabbed off of that spur gear I created, and I modeled the real geometry that I wanted into that bevel gear, and in the next step I removed that tooth altogether. And it made it so much easier to get that tooth profile exactly the way I wanted it. And if you use this technique, you'll be able to model complex geometry with greater ease. I want to take a brief pause right here to say that if you really want to learn CAD, the best way is to hire a coach. A coach will give you direct access to an expert who can guide you along the way, answer your questions as they come up, and hold you accountable. Hiring a coach will also drastically increase your commitment level. So while there's a lot you can learn on your own, the fastest way to shortcut your path to success is hiring a coach. If you're interested in learning more about my CAD coaching program, the 3D Printing Design Accelerator, comment CAD Coaching below and I'll send you additional information and a link where you can apply to find out if you'd be a good fit for the program. Now let's get back to the video. Number 4, name your sketches. A beginner tries to save time by rushing to the next feature. An expert saves time by clearly organizing and labeling everything they've created. This may be a bit of a controversial topic, as I know there are a lot of CAD experts out there who don't name their sketches, but you are better off naming them. I view this similarly to commenting your code in computer science. It's so much easier to look at an old design or old code when you've added comments, and that's what naming your sketches does. And you can see a completed version of that Plinko game I was talking about. You can see that I labeled all 4 of the sketches so I knew exactly what they were used for, and I also grouped features along the timeline and named those groups: extrude block, extrude pegs, extrude border, and so on. And the more complex your design becomes, the more valuable naming your sketches is. This is definitely not the most complex design I've made. I created a 3D printed guitar a couple years ago, and maybe you've seen it hanging on the wall in the back of my videos. And that guitar had many features and many sketches, and I worked on it over the course of a year. Fortunately, I did myself the favor of naming my sketches and grouping together and labeling my features so that whenever I would take a break for a couple months, I could go back and immediately find where I was at. And I would use the 3D printed guitar as an example, but unfortunately, it is trapped on my student account of Fusion, which is difficult to access at this point. Nevertheless, the important thing is if you name your sketches, you will find it much easier to modify old designs down the road, and it will be easier for other people to understand your complex designs. Number 5, build the assembly before you design the parts. A beginner thinks you need all the parts before you can assemble the design. An expert uses the assembly to inform the design of each part. Good example are these bevel gears that I created that mesh together at a 90-degree angle. And rather than designing each of these gears independently and then seeing if they would mesh, it made much more sense to first create the assembly and the interface between these gears and then the gears themselves. So if we go back in time to the very first sketch that I created and we unhide this sketch, you'll notice that I've modeled a lot more than just these gears. I've modeled the point at which they'll mesh, as well as the pitch of the teeth, and a lot of other important aspects of the assembly. And then you'll notice that I began with this simple geometry of cones and worked from there to create the final parts. And I created them together at the same time based on how I knew the assembly of the gears needed to function. By using the assembly to inform the design of your parts, you'll save yourself from repeatedly circling back between the assembly and the parts because you'll get the individual parts right the first time. Number 6, iterate using simplified prototypes. A beginner prints a full prototype each time they want to test a design change. An expert prints the minimum necessary. Now this might seem kind of obvious, but it is something that's often overlooked. And a good example is this part right here. And I apologize that it's the mesh version of it. I created the original in SolidWorks, and so this is the easiest way to show it in Fusion. But this part right here has some very tight tolerances on this pin and on this hexagonal orifice at the top, as well as the diameter and depth of this circle right here. And so I had to print this a lot of times, trying different dimensions. I maybe printed it 8 times, and I was using a 0.2 millimeter nozzle, so those prints took a little while. So if I was only testing a change to the diameter of this pin, or maybe this hexagon up here, I only need to print that section. So I could remove the entire bottom, maybe even remove more if I'm just testing the hexagon orifice right here. But by printing this minimal amount, I could turn a 2 or 3 hour print into just 15 or 20 minutes, and I still get the same information and feedback from that prototype. This is extremely easy, and it'll save you a lot of time when you're iterating prototypes on complicated designs, and it'll save a lot of material. Number 7, build failure into the model. A beginner asks how they can prevent the design from failing. An expert asks, where do I want this to fail? Going back to the cylindrical snap bracket, let's say you wanted to mount this in your garage near the entrance holding some object. And maybe you're worried that as you're pulling the car out, it may catch on that object. And without giving this any intentional thought, it's possible that the screws holding this bracket against the wall may get torn out, especially if you're going into drywall or you're using drywall anchors. So one way you could mitigate this is by modifying the design and creating a little neck down region in these arms. And this neck down region would be tuned so that at a certain amount of force, it'll snap right at this point before the screws are able to fail. And this is preferable because you'd rather reprint another 50-cent bracket than spend time fixing a hole in your wall. So by modeling a failure point into your design, you'll be able to prevent surprise catastrophic failures. I hope you enjoyed today's video, and I hope that you'll apply at least one thing that you learned from watching today. And let me know in the comments which tip was most surprising, or what's another tip that you think CAD beginners should know that wasn't covered in today's video. I also encourage you to check out this video where I teach you how to create the perfect snap fit bracket for storing brooms, mops, or any object that has a cylindrical handle. Once again, thanks for watching. Until next time.